Hello class, this is the video for section 4.7, optimization problems. So in this section, we will apply all that we have learned so far in chapters 3, 2, 3, and 4, and to solve real life situations, basically to minimize or maximize the problem. Okay, so in solving such practical problem, the greatest challenge is often to convert the word problem into a mathematical optimization problem. And so we have set up some guidelines in which we're going to go through. Okay, so let's recall the solving problem. What these are the principles. The steps are the following. Okay, always read a question, understand the question carefully before you start solving it. Because as I always say, if you don't understand, then you cannot solve it. So they ask yourself the following questions. What is the unknown? Okay. What are the given quantities? What are the given what conditions in the question? And then draw a diagram, if appropriate, if you can. And then also introduce a symbol for the quantity that is to be optimized. In other words, either to maximize or to minimize. And then we can call that quantity a Q. All right, for now. Now the step 4 is that you express, in addition to that, select symbols for all other unknown quantities in the question, okay, or in your diagram. Now it may help to use initials as suggestive for symbols. So A for area, H for height, and T for time, and so on. Then you express the Q, the quantity that is unknown, that you are supposed to maximize, okay, in terms of other symbols in step 3. And then step 4, you use the information in steps 3 and 4 to express the quantity Q in terms of only, okay, one of the symbols in step 4. And then if you have Q as a function of X, if you call that X, then you can say that your Q that you are supposed to optimize, you express in terms of X. And then when you are finished, write the domain of that function, because that's going to help in finding where the maximum or the minimum or absolute maximum occurs. Okay. Then you use the previous methods that we have discussed in sections 4.1, where you have a closed interval, okay, where there is the maximum, absolute max, and absolute min occurs. All right, and then 4.3 to find the absolute max and absolute min. And so here, the optimization problem is not the local minimum or local maximum that we are looking for. In fact, it's a global, it's the absolute. Of course, if you have a closed interval, then you use section 4.1 that we discussed. All right, so we're going to pick examples and work through that. Okay, so this is a very simple problem. So find the two numbers whose difference is 100 and whose product is minimum. The difference is 100, the product is is minimum. So the step 1 in this case is that what is the unknown? Okay. We know that we are talking about the difference. All right. So the difference in this case is said is 100 between two numbers. And then we also know the product, okay? Okay, which is product of two things which you don't know. So two numbers, product of two numbers. Okay, that will be finding. All right, then step 2 is that a diagram. There's no diagram needed. Okay, in this case, no diagram needed. So then step 3 is that you express the quantities that is given. So my unknown, okay, the unknown quantity here, the unknown quantity we're going to call it what? The product. Let's call it P. Okay, the not quantity, let's call it P. And then we also have as a two numbers. So you're going to let the other numbers, let X and Y be the numbers, okay? Be the numbers. So when it talks of the difference, okay, the difference that is, in this case, either X minus Y or Y minus X, we don't know, there are two numbers. So the difference is what X minus Y is said is equal to 100. And then we have the product, the one that we need to minimize is what the product. So the step 4, it says that your P, okay, the product of these numbers will be X, Y, and then we have to what? Minimize what? This one. So minimize what? Minimize P. Okay. So what we have done, we're going to express the Q, in this case, the P, in terms of only either X or Y, using this equation right here. So we know that from there, your X is equal to 100 plus what? Plus Y. Therefore, my product P will be X times Y, and the Y is 100 plus what? Plus Y. Okay. Then when you multiply it out, you have what? You have 100 X plus what? So I got, sorry, it's supposed to be Y. Okay. Okay, Y times X, which is what? 100 plus Y. So then this is equal to what? 100Y plus what? Y squared. Okay, so you see that we have expressed the P, the product, in terms of only the Y, one of the quantities, the numbers X and Y. Okay, then step 5 is that we have to maximize it. So first, now we have the P is a function of what? The function of Y. So let's find P prime. By the way, what's the domain of this? This is all real numbers, because it could be any number. Okay, so the domain is all real numbers. So let's differentiate this with respect to Y. That gives us 100 plus what? 2Y. And set this to 0. That gives me, that gives us what? The Y. That implies Y is equal to negative what? Negative 50. All right. So if Y is equal to negative 50, what does it guarantee that this is the minimum? The product P is minimized at this value of Y. Okay. Now this is where we have to use either the second derivative test that we talked about. So let's find P prime of Y, and this is going to be what? 2. This is what? Positive. Okay. This is your critical number. Don't forget. That's a critical number right there. The critical number is greater than 0. So you see that the minimum, or we say that P is what? Minimized, or in this case, it's an absolute minimum at what? Y equal to minus what? Minus 50. Okay. Because it is this function here, look at it, it's a quadratic and it's positive, so it's opening or downwards. It's concave down, concave up, and that means it has an absolute minimum. All right. So if that is the case, so what is the X? Your X is equal to the 100. As you can see, it's 100 what? 100 plus what? Plus Y. But Y is what? Negative 50. So that's 100 minus 50 is equal to what? 50. All right. So then, what are my numbers? Okay. The numbers are 50 and what? Negative 450. Now, these are the numbers when the product Product is what? Is minimum. So that solves this question. Now let's check the assignment C. So their difference, what's the difference? X minus Y, which is what? 50 minus 50, which is what? So we can check that to see that's clear. Okay, so that's it. Now here's another question. It says that a farmer has what? 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. It needs no fence along the river. So take note of that. It needs what? No fence along the river. What are the dimensions of the field that has the largest what area? So if I want to understand this, one, he said fencing. It has this fencing. The fencing is what? The fencing means what? It's a perimeter. Fencing is what? A perimeter. So it's perimeter. I'm spelling this. Perimeter. Okay. The fencing is a perimeter. All right. And then with the largest area, I also have what area there, right? That's a quantity. Okay. So we can look at the dimensions. We have to deal with what? Since it has area and it's a rectangular, so we have width, we have the length as well, all included. But let us see some possibilities. So in order to get the fencing for what is happening in this problem, it is experiment. Let's experiment with some special cases. So the figure below gives us some possibilities. All right, so this figure one, it has, if you don't fence the river, okay, along the don't fence along the river, okay, so we're gonna have this kind of what? So we can have 100 and 100, and then the length will be 2,400. That's a possibility. The area is what? Is 220,000 feet, square feet, all right? Now, all we can do 700, 700, and 100. If you add everything, you get 1,000. You get what, 2,400. And what's the maximum? That is it. Or we can have what, 1,000, okay, like that. And then when you multiply, you get what, 400 square feet. So we can do a try and error until we find it. But any of this is a possibility. But to solve the problem, we go to the steps. And first, we're going to define, okay, we will try to, shallow, wide fields or deep, narrow fields, we get to relatively small areas, as we have seen there. It is possible that there are some intermediate, configuration that produces the largest area. So we're going to figure out. So therefore, we go to this figure. And then this is the area, all right? Let's call the width, all right? Let the width equal to X, and then let the length, let's call it Y, okay? So if it's a fencing, that's a perimeter right there, all right? And then we also have the area. Now, let us talk about the area. We're going to let X and Y be the depth and the width of the what? Of the rectangle. So we can express the area as what? As a product of the what? Of the two. Okay? As a product of the two. Now, according to this, what do we have? Okay? If you go back here, this is my diagram. So this is the, basically, this is the step 2. We have done steps 1 and 2. Okay, so I have the diagram, we have defined it, all right? And then the other things we should know, step 1, we should know that the perimeter, okay, is giving us what, 2,400 what? Feet. And then the perimeter in this case, according to this diagram here, is going to be what, 2x plus y is equal to what? 2400, like that. So my perimeter is equal to this. I'm going to have x plus what? Plus y. That's why I got 2x plus y was 2400. All right. Now the area is given. Okay. So I am in steps what? Step 3. All right. I got that. My perimeter is what? That's 2x plus y is equal to 2400. Okay. So we have this. So now the question is that we know the area. Okay. The area of the rectangle is given by that. And so we want to express, okay, the area in terms of what? Everything else. Okay. So we have the area in terms of x and y is that. And then we also want to express everything in terms of what? The step 4 is that find it in terms of one of the quantities. Now from this, we notice that my y is equal to what? 2400 minus what? 2x. Okay, 2400 minus 2x. So the area, which is equal to xy, is x times what? Y, and the y is what? 2400 minus 2x. Now when you put this together, you get what? 2400 x minus 2x what? S squared. So the area now is a function of only one of the what? Of the variables. All right. Then what's the domain of this? What's the domain? Okay, if you set this to 0 and solve for x, you will notice that it's if you factor x out, you get 2400 minus 2x equal to 0. Then you have x is equal to 0. And then if you solve 2x or 2400 minus 2x equal to 0, you get x equal to 1200. So basically, the domain of this function, domain is the what? Is it between what? 0 and then 24 to 1200. Okay, it's a closed interval. So his area could be 0. If x is 0, it's 0. And if it is what? 1200 is that. So therefore, the maximum value will occur within this interval. Now, since it's a closed interval, I can use what? Find the critical value. So first, let's differentiate. Let's differentiate A. You have what? 2400 minus 2x equal to what? Equal to 0. Okay. So this is actually 4x. Okay. So if you set it to 0, you get what? 2400 minus 4x equal to 0. And then x is equal to the 2400 over 4, which is what? 600 feet. Now, since it's a closed interval, we use what? Section 4.1. Okay. So from section 4.1, we see that that's where we find the absolute what? Absolute values. And this is A of x. So we have 0, we have 600, and then we have what? 1200. Okay. Now, don't forget, this is my what? Critical number. So let's evaluate when x is 0, the area is what? 0. When x is 1200, the area is also 0. So when x is 600, okay, you are going to have this value will be what? 720,000 square feet. Okay, 720,000 square feet. All right, so you could see that this is what? Definitely my what? The absolute maximum area. Okay, that's it. Square feet square. Okay, square feet. So what is happening is that we say that the area is maximized. That's absolute at what? X is equal to 600 feet. Right. Or alternatively, okay, alternatively, after getting this, I can find the second derivative, which is what? A prime prime of x, and that will give me -4. And -4 is what? It's negative. Now, don't forget that if the second derivative is negative, then we say that A, the area, A has what? Has what? Absolute maximum value. X equal to 600 feet. So if X is 600, what is Y? Well, we know that Y is equal to, according to this one we have here, Y is equal to what? 2400 minus 2x. Then that is 2400 minus 2 times 600. And that will give me 12. So area is maximum, okay? Area is maximum when X is what? Or in other words, the rectangle will have the dimensions 600 feet by 1200 feet. Okay. All right. So that is what we have here. And then we have that. That will be that'll be my answer. All right. Now, sometimes we can use the first derivative test to find the what? Absolute max and absolute minimum. Remember, we say we can use it to find the minimum. Right? Local maximum, local minimum. But we have is also for the absolute extreme values. Okay. So C is always your critical number. So you differentiate, and for all x in the domain, okay, for all x what less than or less than what the critical value, that is all the values to the left of what the critical value, the f prime is what? Is positive. And all the values to the right of the critical value, the f prime is what? Is negative. When that happens, we have what? Absolute what? Maximum. Now this is the same as we discussed before. Yeah, this is my C. Okay. Now every x to the left of that, they say this is what? This is positive. And every x to the right of the critical number, the f prime is what? Is negative. And don't forget if it's like this. Okay. It changes from what? Positive to what? To negative. And so that's why I have what? Absolute what? Maximum. And on the other hand, if you have C and everything to the left of that, it is actually negative. That's my C. And then to the right of the critical number, the F prime, this is what the graph for F prime is positive. Then it has what? Absolute what? Minimum. So I'm going to do two problems, and one of them will go to show that this is what we have the absolute maximum using this first derivative test. All right, now here is another simple problem where it says that find the two numbers possible now whose product is what? Is 100 and whose sum is minimum. Okay, so I'm going to let x and y be the numbers. X and y be the numbers, right? Now, the x and y be the numbers, we know that it says that the product, okay, the product of these two numbers, which is xy, is equal to 100. Okay, so from this, we can solve for one of the variables and say, let's say y is equal to 100. And then he said the sum, let's use s for the sum. The sum is what? X plus what? X plus y. And then we need to what? Minimize this. Minimize s in this case. Now when we plug in y, this expression here for y, then the s is equal to x plus 100 divided by what? X. All right. So now this becomes a function of x. Now we want to minimize that. By the way, what's the domain of this? Okay, it's all real numbers, and then 0 to what? Positive infinity. Because if x is 0, then this is undefined. We're going to have 100 over 0 is undefined. So that's why we have this domain. All right. So now let's just differentiate this. Okay, let's differentiate s of x. That will give me 1 minus 100 over what? S squared. All right. Now, if we set this to 0 to find the critical numbers, we're going to have what? X squared is equal to 100. And then x is equal to plus or minus what? Minus 10. All right. So now let us have what? Using the first derivative test. Here is my negative 10. That's my positive 10. Okay. So if you test it over the interval, okay, if x is negative, say negative 11, you will get 1 minus 100 divided by negative 11 squared, which is 121. That is less than 1. So this should be what? This should be positive. By the way, this is the graph for s prime of x. Okay. And then on this side, in between that, if I use, cannot use 0, I can use 1. 1 minus 100 over 1 is negative 99. And this should be what? This side will be what? Positive. So you see that it is changing from what? Negative to positive at what? Positive 4. But here we have what? Absolute mean. Over here we have what? Absolute what? Max. But the question says find the what? Where the sum is what? Minimized. Okay. So here we say that the sum S has what? Has what? Absolute value at x equal to what? Positive 10. Okay. So if x has positive 10, then what is y? Then y is equal to 100 over x, which will be 100 over 10. And that is what? That's 10. Therefore, the sum is what? Minimize when the two numbers are 10 and what? And 10. Then we have one more application to business and economics. All right, so we have this example. Let's talk about some terminologies there. Okay, we're going to denote Cx as the cost function, and then the marginal cost is the derivative of C. So C prime, okay, C prime is what you call the marginal cost. So this is the cost of producing X units of what? A certain what product. Then the marginal cost is the rate of change of with respect to what X. In other words, the cost of producing an additional unit, okay, of the product. All right. Now we're going to consider P of X be the price per unit function. Okay. You sell what? X units of the product. And then we have called the demand function. So P is called the demand function, or we also call the price function. And we will expect it to be a decreasing function, because if demand and price is going higher, okay, sometimes most commodities, the demand goes down. All right. If price is high, we won't buy unless it's a necessity. Well, we will denote R of X as what we call a quantity times what the price. Okay, that's your revenue or function. Okay, so the marginal revenue is what the derivative of what R, which is what the R prime is what the marginal what revenue. Okay, and then we also will call the P, capital P of X will be the profit function, and profit is what the marginal, so the revenue minus what the cost function. Okay, so revenue, this is what the revenue function minus the what the costs what function. Okay, that gives me the profit function. Because so the marginal profit is what the P prime, the derivative of the profit function. So here is an example. Okay, it says that a store has been selling 200 flat screen TVs a week at $350 each. A market survey indicates that for each $10 rebate offered to buyers, the number of TVs sold will increase by 20 a week. Find the demand function, okay, and the what? The revenue function. Remember, the demand function is the same as the price function. Now the question is that how large a rebate should be stored. So should a store offer to maximize its what revenue? So we want to maximize revenue where to determine what the value, the, the rebate to what value, okay, price that should be given to what customers. Now, in solving this, we'll let X be the number of TVs sold per week. Now, according to the question, the sales is what? It said it to be 200 minus what? So weekly increase in sales will be X minus what? 200. Okay, the store has what? 200 flat screen. So, all right. And so, if you want to know how much is left, we have that. Now, it says that for each increase of 20 units sold, the price is decreased by what? By $10. So the question is, what is the price reduction per unit? Okay. So for each additional unit sold, the decrease in price will be what? 1/20th of $10. Okay, which is the same as what? 10 over 20, or you can write it as 1/2. Then what is my demand function? Okay, the demand function, don't forget, it is what? Go back. All right, how much do you sell each? Okay, it's 350. So it's going to be 350 minus, okay, the price per unit, all right, times how much is what is sold. You go back here, that is what? The weekly increase in sales, which is what? X minus 200. And so that's why we have this expression. Now, when you simplify that, you get what? 450 minus 1/2 what? X. So then what's the revenue? Revenue is what? X times the price function. Okay, number of quantities times what? Price per unit. And so this gives me that expression, which is what? Which is quadratic, right? It's quadratic function, and is what? It is concave up because it's, sorry, it's a concave down. So because it's going to have something like this, and therefore it's going to have a maximum value for sure. All right, so then if I differentiate the revenue, which is the marginal revenue, we differentiate this function here, we have what? 450 minus X, because this is 1/2 times 2, which is go away, and that'll cancel out. So we have 450 minus X set to 0. So we have X is equal to what? 150. Now this value of X gives an what? Absolute what? Maximum by the first derivative of test, or by simply observing that the graph of this is a parabola that opens what? Downwards, like I've said. So we say that there's the X, it gives what? The revenue, the absolute maximum value. All right. So then, if we plug in into the price, we said we should find the demand function. Okay, how much the price should be. So if X is equal to 450, into that, we get what, 225. And the rebate is 315 minus that. Rebate 315 minus that. So because when you subtract it, that's what gives me what, 25, 125. Therefore, the maximum revenue, okay, to the maximum revenue, the store should offer what, 125 dollars in rebate. Okay, so just $20 is not enough. But if they want to get maximum revenue, they should do this and they will not run at a loss. In fact, they will gain profit. All right. So that is the end of this section. I'll see you again soon. Bye.